Okay, in this tutorial we're going to be looking at sketching graphs of y equals the modulus of f of x, y equals f of the modulus of x, and y equals f of x. So what we're going to look at to start off with is just one of our normal cases of y equals f of x, and this one that I've drawn is y equals x plus 1, okay, as we'd expect. Now when we have a look at, firstly, y equals the modulus of f of x, basically that means that anything below the x-axis now becomes positive. Because remember, our modular sign makes anything that's a negative value in here a positive value. So that means that anything that's below our x-axis becomes positive. So in this case, this gets reflected in our x-axis, and the rest of the equation is unchanged. Okay? If, however, so that's for our y equals the modulus of f of x. Okay. If, however, we look at y equals f of the modulus of x, okay, basically what that means is all our negative values for x now get treated as positive values of x. So the difference with this one, okay, is that we actually reflect it in the y-axis. So negative 1, is treated like positive 1. So we don't have a value of 0, we actually have a value up here of 2. So we actually end up going like this. So when we have our y equals the modulus of f of x, reflect what's below the x-axis in the x-axis, and for y equals f of the modulus of x, then we reflect in the y-axis. So anything on the right-hand side gets reflected in the left-hand side. Okay, and we can talk about that a little bit more formally. Okay, so when we have y equals the modulus of f of x, okay, it's quite often useful to define that as a piecewise function. So that we can write as y equals, well, it's f of x when our function f of x is bigger than 0, or when our function is positive. Okay, so that's whenever we're above our x-axis, we're just talking about the normal function, but it's equal to negative f of x, okay, whenever our function has a negative value. Okay, so that was our values below the y-axis, x-axis. Okay. If we look instead at our y equals f of the modulus of x, okay, again we can write this as a piecewise function, okay, and it's written as y equals, well, it's f of x whenever x is bigger than 0, so whenever we're positive, so that's this part of our graph, but it's f of negative x when x is less than 0, okay, which is when we're over here. Okay, so that's just breaks up our modulus functions into piecewise functions where we don't need the modulus line anymore, because often we find it difficult to actually use the modulus function, so when we can, we break it down into multiple functions. Okay. So we'll have a look at another worked example, and this time we'll look at how we solve inequalities. So what we're looking at is we have two functions, y equals x plus 1, okay, and we want to use that function to solve when the modulus of x plus 1, okay, is less than 2x plus 8. Okay, so what we need to do is initially sketch this function. Do some axes. Okay, we know we're going to be like that. Okay, and from there, well, we need to think, okay, well, how are we actually going to use this function? Well, we're using this function to sketch this function. Okay, so because everything is in the modular sign, well, it means that this is a case where we're just reflecting our negative part of our graph. Okay, so we're going to reflect that up here now. Okay? And I probably should have drawn some longer axes there because we're going to have to do our equation of 2x plus 8. So we're going to come right up here somewhere and say this is 8. Okay, and we're going to come through -4 over here. Okay, so we're going to have that situation. Now of course we need to know what this point is. Okay, where do they intersect so we know when we're below this one? Well, we need to think, what equation is this here? Okay, well, it's where we've had to reflect it. Okay, so we actually have negative x plus 1. Okay, and we need to find when that is equal to our 2x plus 8. Okay, so I think, well, this is negative x, take 1, 2x plus 8. A little rearranging, we get negative x equals 2x plus 9. So negative 3x equals 9. Therefore, x equals negative 3. So we know the x coordinate of this point there is negative 3. Okay. Therefore, okay, this is going to be true, okay, for all x greater than negative 3. You can see that 2x plus 8 is larger than the modulus of x plus 1 whenever we're bigger than negative 3. That's our critical point. So that's all we've got for this section. It wasn't too long. So hopefully that helps you to sketch some of our functions.